Okay, in this example, we want to find out the force P as shown here in the figure. Knowing that the H is about 6 meter, R is about 2 meter, and the gate has a 4 meter wide. So as mentioned in this question, the force P should be about to open the gate. It's hinged at the top, and we want to apply force P to open the gate. So in this example, we need to calculate the forces acting on the gate. This is the curved gate. So the forces acting on the gate is the force P, the force happening at hinge, and also the force due to the pressure. Or the most important thing we need to find is the force due to the pressure. To finding the force due to the pressure, since it's the curved surface, we don't have a direct method to find it. So the way we can actually find the force is dividing the force to three main components. So the three main components, including the horizontal force, vertical force, and the force due to the weight. If I show the free body diagram for this particular example, this is the curve, which is our gate. We have force P at this point. We have the reaction force at hinge, or we can call it F hinge. And then we have vertical force. When we're saying vertical force, if this is the gate, it's the force on a projected area. So this is the projected area, and this is the vertical force. We call it FV. And then we have horizontal force, which is the force acting on the projected area in the horizontal direction. We call it FH. And finally, we have the force due to the weight, FW. So in total, we have 5 forces acting on the system, and force P is the one we're looking to find it. F hinge, we don't know it, but we don't actually need to calculate it because we're going to use this total moment around point, the H is 0, so we don't need to calculate F hinge. And we can compute F vertical, F horizontal, and F due to the weight. The location of all these forces is also important, and I will demonstrate in the following. Okay, let's say the first one is the horizontal force. To find the horizontal force, we're looking at the projected area. So this is the curve, and it's about a quarter of a circle. If I'm looking at the 3D, that's actual the gate. When I'm saying the projected area, I mean this rectangular. This is the AH. We can write down FH, it's the rho G H, capital H. This is the pressure at this point. If the height of the water is shown with the H, we know the pressure at this point will be about rho G H. Times area of the surface, we show you with the AH. If I insert the values, it will be about 1000 density of the water times gravity times H is about 6 meters times the area. Area, the gate is about 4 meters wide times, and this radius is 2 meters. So FH will be equal 470.88 kilonewtons. We also need to know the location of this force. Since this is the horizontal, it's acting on the centroid or the center of the plate, which gonna be, and it's a rectangular, so it will be at the center. And I need to find the distance from the hinge point. So that's the distance we need to find. This is, we call it XH, and XH will be equal half of the radius, which will be about 2 divided by 2 will equal 1 meter. Okay, the next one is the vertical force. So vertical force, we show you with the FV. It's a rho g h bar. We want to find the forces acting on this vertical gate times area. If I just look at the projected area in the vertical, then the the pressure distribution will be like that. And I need to find the force. This is the vertical plate. So that's the force, FB, and it's actually the location of the force will be center of pressure for this vertical plate. To find the vertical force, we learn it's equal rho g times h bar times area. H bar is the distance from the centroid up to the free surface. So if this is the projected area, it's a rectangular, the centroid is in the middle, and that's the h bar. Then we can set that h bar is equal capital H plus half of the R, which will be 7 meter here. H is 6 meter, R is about 2 meter divided by 2, 1. The H bar will be 7 meters. And the projected area in the vertical direction, again, it's the 2 meters. This length is 2 meters times its width, which is 4 meters. If I then insert the values, the density of the water 1000 times gravity times 7 meter times 4 times 2, which is the area, and FV will be equal 549.36 kilonewtons. And now it's a location of this vertical force. So we learn to use this formulation. YP is equal Y bar plus I bar divided by Y bar times area. What is the Y bar? Distance from the centroid of the plate or gate to the free surface. I is the second moment, A is the area. So in this example, because it's the vertical, I bar and H bar are the same. Then here they are the same, which it means Y bar is 7 meters. Plus I, it's for the rectangular, the formulation is 1 divided by 12, 2 power 3 times its width, which is 4 meter here, divided by Y bar is 7 meter times area, and area is 4 times 2. So the final answer will be 7.0476, and the unit is meter. Okay, keep it in your mind, YP is measured from the free surface. So if YFV acting here, this is the YP. But what we need the vertical distance to the hinge. So I need to then deduct the value of the H, which is 6 meters. I'll call it Z vertical, which can be obtained by using YP 476 minus capital H, which is 6 meter. So the distance from the vertical force acting to the hinge point is 1.0476 meters. Okay, we find the vertical force, its distance from the hinge. We find the horizontal force and its distance from the hinge. The last one is the weight, the force due to the weight of water trapped in this area. As shown here, we want to find the weight of water. So we know the density of the water. We can find the volume of the water here, which is a quarter of a cylinder, and then we can find the force. The third force is the force due to the weight. We can show you with the FW, which is the density times gravity times volume. Density is 1000, gravity 9.81 times the volume, a quarter of a cylinder. So P times 2 square, and the width of this cylinder is 4 meters. So FW will be equal 123.276, and the unit kilonewtons. Okay, just keep it in your mind, we're expressing all the forces in kilonewtons. Okay, and the last one, the location, the distance from the, again, hinge point. So if the FW acting here, this is the FW, we want to find this distance. We can call it as a XW, and then it can be written as R minus 4 times R divided by 3 times P. So the force due to the weight is acting at the center of gravity for that particular shape, which is a quarter of a cylinder. Then we can find the value of the X, which will be 1.151 meters. Okay, now we have all the forces. If I redraw the free body diagram here, so that's our gate. I'm just going to make it a little bit larger. This is the hinge. So the forces we have F hinge. It's important to show all the forces acting. We have P, the required force to open the gate. And we also calculated F vertical, F horizontal, and also FW. We obtain all the required distance. So this is XW. This is, we show this one with the XH. This one with ZV. And of course, this one is R. Okay, we know all the forces, we know the distance from these forces acting to the hinge point. Now we know the system is equilibrium, so then total moment around the hinge point should be equal 0. I'm selecting clockwise as a plus, as a positive sign. Then I can write down F hinge doesn't produce any moment because the distance is 0, minus FH times XH plus force P times its distance, which is R, minus FV times ZV, minus FW times XW should be equal 0. I have all the parameters. If I insert the value, the only unknown parameter is P, which I can then calculate. P will be equal 594.145 kilonewtons. Because all the forces are expressed in kilonewton, all the distance are in meters, so the unit for the force P will be in kilonewtons. Okay, to just review again, what we want to find force P that actually, it's required to open the gate. So it means the system, we need to find all the forces or draw the free body diagram. The forces acting is the force P, which is something we're going to find, the force, the reaction at the hinge point, and also we have the force due to the pressure. Since this is the curved surface, we cannot find the force directly. We have to divide it to three components: the vertical component, the horizontal component, and the force due to the weight. So F horizontal, it means the forces due to the pressure acting on the projected horizontal area. F vertical, it means the forces acting to the vertical projected area due to the pressure. For the horizontal force, we actually learn it's a pressure at that particular point times area. The projected area, this is a quarter of a cylinder. So, and this is our gate. So the projected area simply will be a rectangular. So AH is the 4 times 2. And the pressure at this point can be easily found knowing the height of the water, which is about 6 meters. The location is actually acting at the center of this projected area. It means the distance from the location that force acts to the hinge point will be about half of the R. For the vertical force, we know the formulation. The formulation is the rho g h bar times AV. Just keep it in your mind, this is the formulation that we can use when the gate or the wall is either vertical or have an angle, but it's a straight one. Okay, so it's the flat surface, it's not curved. If it's the flat surface, we can use this formulation. Again, what is the H bar? H bar is the distance from the centroid of the area, which is the area of the gate, to the free surface. So the projected area, as shown here, is just, again, a rectangular projected vertical area. And the centroid will be, at the center of this shape. We know the capital H, which is 6 meters, and this distance is about 1 meter. So plus 6 meters, the H bar will be 7 meters. And the area is again 4 times 2. We can find the vertical force. The location of the location that this vertical force acts, or the center of the pressure, we show it with the YP. YP is equal Y bar plus I divided by Y bar times A. What is the Y bar? Is the distance from the centroid of the gate to the free surface along the gate. So here, because it's the vertical, Y bar and H bar, they are exactly same. So we already know what's the Y bar value. I is the second moment of the area of the gate. And if we just insert the value, we can find YP. YP is the distance up to the free surface. But what we really need to find, the distance of the where the force acts to the hinge point. That's the reason we call it ZV, and it's just the YP minus 6 meters. The ZV value will be equal 1.0476 meters. And the last force is the force due to the weight of water trapped between this area. So we need to find the volume. If we know the volume times the density times gravity, we can find the weight. How we can find the volume is just simply a quarter of a cylinder. So if I insert the value, we can find the volume and then we can find the force. Where this force acts at the centroid of, or at the center of gravity for that particular shape, which is a quarter of a cylinder. You know the formulation for the quarter of a circle. You can actually use this formulation, but it's the distance from the side. We want to find the distance from the hinge. That's the reason we have to deduct it from our value. Now we found all the forces. We know their location. We can use the total moment equals 0 to find out the force P, which is this one. If I insert all the values, then we can actually obtain the parameter.